गुड मॉर्निंग। आज की क्लास में डीकेएस एकेडमी लाइव आपका हार्दिक स्वागत करता है। और इस क्लास में आज ऐसे स्टूडेंट्स को इंक्लूड किया जा रहा है जो कि आपके फोर्थ कमिंग बोर्ड एग्ज़ाम में अपीयर हो रहे हैं, 12th की बोर्ड एग्ज़ाम में अपीयर हो रहे हैं। और जहाँ पे आपको फिजिक्स की सीरीज शुरू की गई है जिसमें कुछ महत्वपूर्ण प्रश्नों से अवगत कराया जा रहा है। और उसी प्रश्नों के अंतर्गत एक टॉपिक है लॉ ऑफ रिफ्लेक्शन, जो कि बहुत ही काफ़ी इम्पोर्टेंट टॉपिक माना जाता है और किसी ना किसी वे में एटलीस्ट 5 to 7 मार्क्स का जो है क्वेश्चन इसमें से पूछे जाते हैं। तो फ्रेंड्स, एज यू नो लॉ ऑफ रिफ्लेक्शन यू हैव ऑलरेडी स्टडीड अप टू 10th लेवल, और the law of reflections you have studied with the help of rays of light. So first we will see what type of questions they are asking in board exam. Suppose they are asking what are the laws of reflections. Prove that angle of incidence and angle of reflection as per HSC wave theory. So this is a question. What are the laws of reflections? That we know very well. With the help of ray of light we can show it. But further prove that angle of incidence and angle of reflections are equal, you can say are equal as per HSC wave theory. So this portion is included in your 12th syllabus, and when board is asking this type of question in your exam, you have to be considering HSC wave theory. So there is one difference between the law of reflection which we have studied in the standard 10th and law of reflection which we are already studied in our 12th level. That in 10th we are considering only a single ray, but nowadays we are considering not only single rays but the all rays between two parallel rays. So they are in the form of waves, and we are proving law of reflection with the help of wave, that is wave theory, which is given by HSC. So first we will see what are law of reflection, then only we'll prove it with the help of wave theory or HSC wave theory. So for law of reflection you have to draw a simple diagram. This is XY, this is your plane. This is your incident ray, you can say A and B. This is your reflected ray, that is C and D, and this is your normal, you can say M and N. The angle between incident ray and normal is known as angle of incidence, that is angle I, you can say angle I. and the angle between normal and reflected ray is known as angle of reflection, that is known as R. So major angle I equal to major angle R. This is your first law which we have to prove in this question as per wave theory. So first law is that angle of incidence and angle of reflection both are equal. That is first law. Second law says incident ray normal and reflected ray all are in the same plane. Which we can see in the figure. Plane is XY, incident ray AB is on this XY plane, reflected ray is also originating from this XY plane, and MN normal is also on that plane only. So they all are in same plane. Third law says incident ray and reflected ray both are opposite side of normal. So second and third law we can prove with the help of this diagram. Even in wave theory also we can prove that first thing, these all things, ray of incident, ray of reflection and normal are in the same plane, and secondly ray of incident and ray of reflection are on the opposite side of the normal. Here MN is normal, AB is at one side and CD is at other side. So all these three are laws of reflection, and now we have to use Huygens theory to prove this laws of reflection, that is measure of angle I equal to measure of angle R, that is incidence and reflected angles are equal. So let us draw a new diagram for this, like this one. This is your XY plane. And let us consider a ray this is a ray that is A1. This is a ray that is ray of incident, you can say, and again this is, you can say, ray of reflection. That is, you can say, this is T and this is your normal. You can say it is MA1. This is normal, means 90 degree angle. Again we will consider another ray parallel to the A1, so it will come like this, and this will designate as BB1. So this will be A, this will be, and this is a form of waves because there are number of rays in between ray A1 and BB1. So this form a wave. Now here is also again reflected rays, because once ray of incidence gives a reflected rays, here is also normal. So you designate it as a, you can say NB1, and reflected ray is your B1Q. So this is your AB is the waves, and in lieu of that, here you will get a tangential semi-circle in form of tangential, and we will have here, this is a P that is having 90 degree. So meaning that first here AB is the wave theory, primarily it is a wave, and these means these waves produce secondary waves at the A1P. Here we will produce secondary waves, and these waves come to this mirror, that is same plane, and it will be reflected back. Here also we are having same angle I and angle R, angle of incidence and angle of reflection. So this is your tangential form. This wave is converted in the reflection in the tangential form, and we will have both angle of reflection and angle of incidence. That is, firstly we are considering primary rays or primary waves. After that we are regenerating secondary waves, and we are getting that angle of reflection here and here. In both ways they are equal, magnitude is the same. So this is the diagram for proving the laws of reflection. Angle, measure of angle I equal to measure of angle R. Now let us see what content we have to give in. For this diagram is okay, but what content we have to give, in what way we have to prove. So first we will see as per diagram xy is the plane, then A1 is angle of incident ray, then A1T is reflected ray, then MA1 is normal. Similarly, BB1 is secondary incident ray, and you can say incident ray only, we will not classify it secondary or primary. And B1Q is reflected ray. Here I and R, here also I equal to angle of incidence and R equal to angle of reflection. So we will see next step. As you have done data, You copy out this diagram and data of this diagram. Again we'll see first point. A plane wavefront AB advancing obliquely towards the plane reflecting surface XY as shown in the figure. That is your plane surface at which incident ray comes and reflected back. Then next you can say A1 is incident ray and you can say like this, A1 and B1 are incident ray. Secondly, when incident ray reaches at A1 and B1, it get reflected. And reaches to point P at a distance of PB1 in time interval T. Thirdly, third point, let T be the time taken to cover distance PB1 during this time interval secondary wavelets are emitted from A1 and will spread in form of hemisphere which is shown in the figure with the help of a semicircle. The distance covered by a secondary wavelet to reach from A1 to B in time t. Time t is the same as distance traveled by primary wavelet to reach from B to P. Hence we can say A1R equal to PB1 equal to CT. Then next point, all other rays between AA1 and you can say BB1 will reach XY after A1 and before B1. So you will get a wave form between A1 and B1. And they will emit secondary wavelet decreasing in ready. Further, we will see after getting secondary wavelet how angle of incidence and angle of reflection are generated. The surface touching all such hemisphere is RB1, which is reflected wavefront, So we are getting reflected wavefront with the help of that hemisphere, and they are bounded with reflected rays A1R and B1Q. So in between two rays, reflected rays, we are getting reflected wavefront. Finally, next draw A1M perpendicular to XY and B1N perpendicular to xy. Then we will get angle of incidence, that is I, equal to major angle A1M, and that is equal to major angle B1N. Similarly, angle of reflection equal to angle M1R equal to angle NB1Q. As per law of reflection, both angles were shown equal because they are in between same wave and wavelet. So we will see angle RA1B1 equal to 90 minus R, and angle PB1 and A1 equal to 90 minus I. Again, in triangle, you can say A1, R1, B1 and triangle A1, PB1. A1R equal to A1B, that is reflected ray, then A1B1 equal to A1B1, that is common side, and finally angle 90 minus R equal to angle 90 minus I. So triangle A1 R1 B1 similar to congruent triangle A1 PB1. That is your AIIMS test. Therefore, angle I equal to angle R, and this is proved that angle of incidence equal to angle of reflection. It may be ray theory or wave theory. In both theory, you will get angle of incidence when any light incident at mirror at plane, then reflected rays are there, and angle made by normal and incident ray and angle made by normal and reflected rays both are equal. So dear students, this is most important questions for you for your forthcoming physics paper 2. So today you got one most important questions, and I think this class is very useful to you, and you continue. If you have seen this video nicely, you subscribe, like, and you tell your friends about this course, that some revision course is going on in physics, so they can also attend. Thank you.